Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the sight distance. As we know, the feasibility to see ahead is a very important for the safe vehicle operation on the highway, and sight distance plays an important role for the same. As sight distance is the length of the road visible ahead to the driver at any instant from the specified height above the carriageway. The restrictions to the sight distance may be caused by the horizontal curves by the objects obstructing the vision at the inner side of the road or at the vertical summit curve or at the intersections as shown in the figure. There are three sight distance situations which are considered. First is the stopping or the absolute minimum sight distance, that is SSD. Second, safe overtaking or passing sight distance, that is OSD. Third, safe sight distance for entering into the uncontrolled intersection. And apart from these three situations, the two more situations are considered by the Indian Road Congress. First is the intermediate sight distance, and next is the headlight sight distance. Now the stopping sight distance, in short, it is the minimum sight distance available on a highway at any spot which should be of the sufficient length to stop a vehicle traveling at a design speed safely without collision with any other obstruction. So that is the minimum distance available with the driver to stop the vehicle without any collision. Next is the overtaking sight distance. The minimum distance open to the vision of the driver of a vehicle intending to overtake slow vehicle ahead with safety against the traffic of the opposite direction is known as the minimum overtaking sight distance, that is OSD, or the safe passing sight distance. So this will be minimum distance open to the vision of the driver so that he can overtake the slow moving vehicle in front of him. And third is the sight distance at intersection. The driver entering an uncontrolled intersection, particularly unsignalized intersections, that means where there is no any provision of a signal, circle, or the traffic police. So in that case, he has to have the sufficient visibility to enable him to take control of his vehicle and to avoid collision with the another vehicle. So that will be the sight distance at intersection. Next is the intermediate sight distance. The intermediate sight distance is defined as twice the stopping sight distance. When overtaking sight distance cannot be provided, the intermediate sight distance is provided in order to give limited overtaking opportunities to the fast moving vehicles. Next is the headlight sight distance. This is the distance visible to the driver during the night driving under the illumination of the vehicle headlight. So it is clearly understood that whatever is the illumination caused by the headlight of the car, that distance will be termed as the headlight sight distance. Next, the stopping sight distance in detail. So the stopping sight distance is the minimum sight distance available on the highway at any spot to be sufficient length to stop the vehicle traveling at a design speed safely without collision with any other obstruction, and the absolute sight distance is therefore equal to the stopping sight distance, which is also sometimes called as the non-passing sight distance. And it depends upon first the feature of the road ahead, whether it has the horizontal or a vertical curve. Second, height of the driver I above the road surface. Third, height of the object above the road surface. Now on the summit curve, the height of the driver I and the object above the road level are more important. The Indian Road Congress has suggested that the height of the eye level of the driver as 1.2 meters, whereas the height of the object as 0.15 meter above the road surface. The criteria for the measurement of the stopping sight distance. As you can see from the figure, the height of the driver's eye above the road surface H is taken as 1.2 meters as recommended by the Indian Road Congress, whereas the height of the object above the road surface H is taken as 0.15 meters. Now the factors affecting the stopping sight distance. The distance within which a motor vehicle can be stopped depends upon the factors listed below. First is the total reaction time of the driver. Second, the speed of the vehicle. Third is the frictional resistance between the tires and the road. Fourth, the efficiency of the brakes. And fifth is the gradient of the road. Here, first we shall discuss on the total reaction time of the driver. The total reaction time of the driver is the time taken from the instance the object is visible to the driver to the instance he applies brakes effectively. The amount of time gap depends on the several factors. During this time, the vehicle travels certain distance. Thus, the stopping sight distance increases with the increase in the reaction time of the driver. It may be split into two parts. First is the perception time and second is the brake reaction time. Now first we shall discuss the perception time. The perception time is the time required for a driver to realize that brakes must be applied. Is the intellection time, and it is the time required for understanding the situation. It is also the time required for comparing the different thoughts, regrouping and registering new sensations. Next is the emotion time, and it is the time elapsed during the emotional sensations and disturbance such as fear, anger or any other emotional feelings such as superstition, etc., with reference to the situation. And lastly is the volition. Volition is the time taken for the final action. It is also possible that the driver may apply brakes without even thinking. So this PIEV theory works on the PIEV time of the driver depends on the several factors such as the physical and psychological characteristics of the driver. The total reaction time may vary from 0.5 seconds for simple situations and 3 to 4 seconds for the complex problems. Next, we shall discuss on the analysis of the stopping sight distance. Stopping sight distance is the sum of the lag distance and the braking distance, with lag distance being the distance traveled by the vehicle during the total reaction time known as the lag distance, and it is equal to V multiplied by T in meters, where V is the design speed in meters per second and time T is the total reaction time in seconds. Generally, it is taken as 2.5 seconds. According to the Indian Road Congress. If the velocity v is in kilometers per hour, then the lag distance can be calculated as 0.278 v into t, where velocity is in kilometers per hour and the total reaction time is in seconds. The Indian Road Congress has recommended it to be taken as 2.5 seconds. Now the braking distance. It is the distance traveled by the vehicle after the application of the brakes to the dead stop position. For a level road, the braking distance is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. The work done against the friction force in stopping the vehicle is given as F into L equals to FWL, where W is the total weight of the vehicle and the kinetic energy at the design speed of V in meters per second will be 1 half into mv square. Hence, braking distance can be calculated by the formulae v square upon 2gf, where g is the acceleration due to gravity, taken as 9.8 meters per second square, and the stopping side distance can be calculated as lag distance plus the braking distance, where SSD can be calculated equals to 0.278 v into t plus v square upon 254 f, where v, that is velocity, is in kilometers per hour. The coefficient of the longitudinal friction, as you can see from the table, the speed in kilometers per hour and the corresponding longitudinal coefficient of friction is given. So for the speed of 30, the longitudinal coefficient of friction is 0.4. 40 for 40 kilometers per hour speed or velocity, it is 0.38, 50 0.37, 60 0.36, and with the velocity greater than 80 kilometers per hour, the coefficient of friction is 0.35. For a two-way traffic single lane road, stopping side distance will be equals to the twice of the stopping side distance. That means you will have to take the twice of the stopping side distance. And in one-way traffic with single or more lane, or two-way traffic with more than single lane, the minimum stopping side distance will be equal to the calculated stopping side distance. With this, we shall stop. Thank you.